All right, you guys, welcome back here. We're going to pick right back up where we left off yesterday, talking about tangent and cotangent functions and their graphs. There's one really big point that I didn't really get to yesterday. I sort of forgot to mention it. I was really trying to get to domain and range, and so I sort of omitted this. And it's from a setup perspective, it's going to be really important for you guys. It's going to make things seem significantly simpler today, okay? So basically what it boils down to is this, you guys. I know that, we've talked pretty extensively recently about the sine and cosine curves, and the first thing we do is we identify how long it takes us for one period of the curve, and we use that to find the first four increments, so the first four marks, so the first four x-axis values, right? So typically the first four are 90, 180, 270, and 360. But what I need you guys to really embrace right now is this. When we do that, we're actually finding the first 5 points, okay? Because the first point is always on the x-axis. So if it's the sine curve, you're at 0, just count them. We're at 0, then we're up to 1. Then we're back to 0, then we're down to -1, then we're back to 0. So it's 5 marks, it's 5 points in our first 4 intervals. It's the same thing for our cosine curve, right? We start out up at 1, down to 0, down to -1, back up to 0, back up to 1. So again, our first 4 intervals are 90, 180, 270, 360, but that gives us our first 5 points because our first point always is, on the x-axis, or excuse me, above the x-axis or on the x-axis, but at 0. What I need you guys to really embrace right now is this. We're going to do the same thing. We're going to focus on 5 points when we're focusing on our tangent curves or our cotangent curves. So what we saw yesterday is this. For one period of this S curve that represents the tangent graph, it's only 180 degrees. It's half the total length that it typically takes to construct a curve for sine and cosine. Instead of it being 360, it's only 180. The part I really need you guys to focus on, though, is we're still looking for 5 spots, okay? It's just those 5 spots are not necessarily 5 points. What we're finding, though, instead is this. We're finding one asymptote, another asymptote, the midpoint of the curve, and that's kind of where we left off yesterday. If you look at this, it appears as though there's only 3 key points in here, but there aren't. There's 2 other ones that I forgot to mention, and they are 45 degrees and -45 degrees. If you go to your calculator and you hit, because this is tangent, if you hit tangent 45, and we don't even need to go to our calculator, if you just think of a 45-degree angle on a right triangle, here's a 45, 45, 90 right triangle. Remember the markings are, we always put 1, 1, and √2 on here. Well, if you're looking at either one of these 45-degree angles, what is its tangent value? The tangent value is going to be 1/1. So what I want you guys to understand here is this. Not only do we have our 2 asymptotes at the beginning and end of this period, we also have the midpoint, but we also have a 45-degree angle. At 45 degrees, the tangent value is up here at 1. That's the point I failed to mention yesterday. And again, I was just so focused on getting domain and range and all that stuff and how we write our asymptotes that I just kind of glanced past it. And then here, for a -45-degree angle, it's the same thing. It's 1/1, but we're actually going to be down here at -1. So what I want you guys to see here is this. The first thing we do when graphing a sine curve or a cosine curve is we find our period length and we use the length of that period to get our first 5 dots. It's going to be the same concept for tangent and cotangent, except we're going to find our first 3 dots and our beginning and end asymptote, okay? And this will make more sense when I turn the page here and get into the examples. And again, the examples I'm not too worried about you having copied in your notes or not, but the one last thing I would like you guys to put in your notes is this. I want you to put into your notes y equals cotangent theta. We're going to basically list, just like we did up here, where it says for y equals tangent theta. We talked about the period. We talked about where the asymptotes occur. And then we talked about domain and range, where domain is basically just reiterating where the asymptotes are, because wherever there's an asymptote, there is not a domain value there. So here's what the cotangent graph looks like. And I'm not going to over-explain this one. We could do the same exact thing that we always do. We could just compare the sine wave and the cosine wave, just like we did yesterday to get tangent. Remember, tangent is sine over cosine. Therefore, cotangent is cosine over sine. We could do it, but we don't need to. The first period of a cotangent curve looks very similar to the first period of a tangent curve, except instead of it having asymptotes at -90 and +90, the cotangent curve has an asymptote at 0. Okay, we have an asymptote at 0, and we have an asymptote at 180. Okay, so you'll notice our asymptotes are the same distance apart. Here it was from -90 to +90, so one period is 180 degrees. It's the same thing here, but that period is more typical. The period occurs from 0 to 180. And then in between those asymptotes is something very similar to this. At the exact midpoint between those asymptotes, which is 90 degrees, your graph is at 0. Okay, just like it was up here. But what you'll notice, and again, I'm just going to show it to you. We could generate it from these two curves and do it the same way, the long way, but we're not going to. Instead, if you were to go to your calculator and you were to punch in, if you had a graphing or a scientific calculator, and you hit cotangent of 45 degrees, so right here would be 45 degrees. So you'll notice 1, 2, 3, 4, 5. Here's our 5 key points. Here's your 1, 2, 3, first 4 tick marks on your graph. It's going to be the same as sine and cosine. But at 45 degrees, it's actually a +1. And at 135 degrees, it's at -1. So here's what you'll notice about the cotangent curve as opposed to or compared to the tangent curve. The tangent curve is going up from left to right, whereas the cotangent curve goes down from left to right. Just like all you guys had to remember last week was that the sine curve started at 0 and ended at 0, and then it went up and then down. And the cosine curve started at 1 and ended at 1. Here's what you have to remember about tangent and cotangent. You have to remember that the first period of the tangent curve occurs between -90 and +90 and goes up from left to right, whereas the cotangent curve occurs between 0 and 180 and goes down from left to right. Okay, so this is kind of the first period. We're going to fill in all the same stuff that we have here that we filled in yesterday. So the period of this one is also pi radians. The part you have to remember is that it's pi radians, 180 degrees, but it's 0 to 180 rather than -90 to +90. Okay? Then we have asymptotes. And I guess I'm going to put, I don't really have a great spot to put them here. Asymptotes are, our vertical asymptotes are x equals, and now if you think about it, it's 0, it's going to be 180, it's going to be 360, it's every increment of pi. So it's at 0, 1 pi, 2 pi, so this is a little easier to write. It's x equals pi n, where n is an integer. So it's basically, instead of it being at every increment of 90, so -90, +90, 270, 450, it's just at every increment of 180. So every pi radian, it's at 180, 360, 540, and so on. It's at 1 pi, 2 pi, 3 pi, 0 pi, all that stuff. Okay? So then likewise, wherever the location of our asymptotes are, that's the only part of the graph that's not defined for a domain. So your domain is basically all reals except, and I'm just going to write it out, except at asymptotes. And where the asymptotes are is everywhere that there's pi, right? So it's at 1 pi, 2 pi, 3 pi, 0 pi, negative 1 pi, and stuff like that. And then your range is obviously all reals because these keep repeating themselves, or excuse me, not they keep repeating themselves, but each one of these curves goes up forever and down forever. Okay? But again, a lot of this stuff is just excessive. Really what you guys need to remember right now is, again, tangent curve goes up from left to right, but it's between negative 90 and 90 and then repeats itself. Whereas the cotangent curve goes down from left to right between 0 and 180 and then repeats itself. Okay? Everything else, you guys, is exactly the same way that you did it for sine and cosine. So I'm going to give you an example or two here. I do need to keep my video a little bit shorter today because my phone is running out of space. I've already recorded my algebra videos, or my algebra video and my advanced math video. But I do want to show you at least a couple of examples here. Okay, I'm going to hold on for 1 second while I grab my notes. Okay, so we're going to do, I think we'll definitely have time to, but I'm going to try and squeeze in 2 examples here, okay? So the first one we're going to do, we'll make just a real simple amplitude adjustment of 2. So we'll do 2 times tangent, and then we'll go theta plus pi over 4, okay? So again, the nice thing is you do the exact same thing that you always do, okay? The first thing that we do is we identify our period length, but now instead of our period starting at 2 pi, now our period starts at pi. So literally, it's pi divided by whatever the coefficient in front of theta is, which in this case is just a 1. So the length of the period here is still just pi radians. But keep in mind, you guys, what that tells us is this. Okay? What that tells us for our curve here basically is this. It tells us how to label our first 4 marks. Okay? Our first 4 marks are just simply whatever this is. So it takes, because we're still finding 5 spots here, it's just instead of finding 5 points, we're finding 3 points and 2 asymptotes. So you label your 4th tick mark pi, and then you split that in half, pi over 2, split that in half, it's pi over 4. So every tick mark on this graph, or everything on our x-axis, is 1/4 of pi. So 1/4, 2/4, 3/4, and then we can keep going here as far as I need to. This would be 4/4, 5/4 pi, 6/4 would be 3 pi over 2. But I'm also going to go back to the left a little ways, because remember, tangent typically goes from negative 90 to positive 90. That would be negative pi over 2 radians to positive pi over 2. So this is negative pi over 4 and then negative pi over 2. So I don't really want to flip back here, but I want to remind you guys, where does the asymptote usually go for a tangent curve? It goes right here at negative pi over 2. Okay, and then positive pi over 2, because that would be negative 90 and positive 90. But let's list everything else. Is there a phase shift here? There is. There's a phase shift anytime there's parentheses. So the phase shift is the opposite of this constant, so negative pi over 4 over whatever your coefficient here is. Well, again, that's just a 1, so it's just negative pi over 4. Let me explain to you guys what this means. Instead of my usual spot, where my first asymptote is at negative pi over 2, I need to shift it 1/4 pi to the left because it's a negative. So here's what this tells me. Instead of, again, my first period going between negative pi over 2 and positive pi over 2, both of those asymptotes are going to shift left. So there's an asymptote, there's an asymptote, because again, the generic one for tangent is between negative pi over 2, positive pi over 2. Okay? All we have to fill in are these 3 marks in between. Okay? Where does the exact middle one usually go? It goes at 0 unless there's a vertical shift. Well, when you look at this one, is there a vertical shift? No. There is no, excuse me. There is no vertical shift. So directly in between my 2 asymptotes right here at negative pi over 4, I'm going to be at 0. what does the tangent curve usually do? It usually goes up from left to right. But remember, that part that I missed out on was that it's usually up 1 unit when you go to the right one and down 1 unit when you go to the left one, unless there's an amplitude adjustment, which there is. There's an amplitude adjustment of 2. So over here, instead of going up 1, I need to go up 2. So here's this half of that curve, and then same thing, when I go back towards this asymptote, instead of going down 1, I go down 2. It's a stretch. So again, it all boils down to the fact that your first thing you do is you find your period length. Here, if it's tangent or cotangent, you're dividing pi by whatever the lead coefficient out here is. But that allows you to set up your first 4 increments, and then you just think back to what it should look like. All I got to do now, because you guys have seen this, it does say write the first or write at least 2 periods. We'll do the same thing. After this asymptote, count 4 more. 1, 2, 3, 4. Put another vertical asymptote there. Right in between them at 3 pi over 4, put a dot at 0. Over 1, up 2. Back 1, down 2. And then you can just draw the next version of this tangent curve. Okay, so what you guys will notice as you get more and more comfortable with this is it's virtually the same process. You just have to basically keep in mind and ask yourself at all times, what does the parent graph look like? What does that first period typically look like? Okay, I think I have just enough time. Hopefully, oh yeah, you guys can just barely see that. I think I have just enough time here to squeeze in one more example. I'd like to do a cotangent one with a whole bunch of stuff on it. So here it is. Y equals cotangent. So no amplitude adjustment here, but a whole bunch of stuff in here. Theta over 2. So that's 1/2 theta. There's an adjustment in front of theta. There's going to be an adjustment after theta, pi over 4. And then there's going to be a vertical shift of +1. Okay? But let's look at how we're going to do this and what it's going to look like. Okay, guys? Okay, the first thing we always do is we find the length it's going to take to cover 1 period. When we're dealing with these curves, we don't divide 2 pi by the coefficient, we divide pi. So this is pi divided by, again, this is 1/2 theta, so it's pi divided by 1/2, which is the same thing as pi times the reciprocal of 1/2, so it's basically 2 pi. So now, instead of this curve taking just pi radians to cover one set of asymptotes, it's going to take 2 pi. But that doesn't change what we do. What do we always do, you guys? We go 1, 2, 3, 4. And we label. It's 2 pi, cut that in half is pi, cut that in half is pi over 2. So now every one of these marks that we're going to put on here, no matter how many we go to the right and how many go to the left, each one of them is half a pi. So 1/2 pi, another half is 1, another half would be 3 halves. 4 halves, which is 2 pi, 5 halves, so 5 pi over 2. Then it would be 6 pi over 2, which is obviously 3 pi. I'm going to stop. I'll add more if I need it. I'm going to go this way just in case. Negative pi over 2, negative pi. But remember, remember guys, this is the cotangent curve. Cotangent curves, asymptotes are usually at 0 and pi, right? So the asymptotes are usually at 0 and 4 on my x-axis, unless there's a phase shift, okay? Let's find the phase shift for this one. There is a phase shift. It's the opposite of this, so the opposite of negative pi over 4 is pi over 4, but then we divide that by the lead coefficient, which is 1/2. So this becomes pi over 4 times 2 over 1. So the 2 and the 4 cross cancel or cross simplify. We're left with pi over 2, positive pi over 2. So think about this, you guys. Instead of my first asymptote being at 0, because this is the cotangent curve, I need to slide it to the right pi over 2, which on my graph is 1 unit. So my vertical asymptote for my first one slides to the right 1 unit. Which means instead of my next asymptote being 4 units over, it has to go over 1. There's always got to be 3 full tick marks in between asymptotes, right? So here's an asymptote. There's 1, 2, 3, 4 tick marks away is my next asymptote. Because I have to have my midpoint and then my 2 points that construct my cotangent curve, okay? before I can construct those, before I can put those, specifically my midpoint, I have to look at the fact that there's a vertical shift of 1. That means my midpoint, instead of being on the x-axis, is going to be up 1 unit. Okay? Then we just kind of address the fact that the amplitude here, there's no lead coefficient, so the amplitude is still 1. All we have to do then is fill in whatever the cotangent curve does. How does a cotangent curve go? From this midpoint, it's going to the right and down 1. So to the right and down 1 is right there. And then to the left is up 1. The cotangent curve goes down from left to right. So you can see there is one period of the cotangent curve that's been slid to the right pi over 2, up 1 unit, but has the standard amplitude of 1. Now all you would have to do, you guys, and I'm going to finish this off here because I'm really just about out of memory on my phone. All I would have to do is draw another one either to the right or to the left. I've got a little bit more room to the left, so I'm going to go this way. My asymptotes have to be 4 units apart. So here's 1, 2, 3, 4 would be right there. So I could squeeze in another asymptote here. And then I just have to replicate this. In between these asymptotes at negative pi over 2 is my midpoint that's up 1 because of the vertical shift. And then I just go over 1, down 1 to the right, left 1, up 1 to the left to draw my second period for this cotangent curve. So at this point, I hope you guys are really embracing the idea that our graphs are all different, our scales are all different, but the work is all very similar in terms of how you construct these. You're going to see it's the same thing or similar thing when we get into cosecant and secant. Okay? So that is the extent. Again, I don't necessarily care if you had these 2 examples copied down, but hopefully the examples will get you to the point where you're comfortable enough with this stuff to be able to do the worksheet, okay? As you guys get going, please let me know if you're struggling. Don't just struggle and say, yeah, I don't get it, all right? Let me know if you're struggling so that I know before tomorrow if we're getting this stuff or if I need to spend an extra day going back through stuff, okay? I really haven't decided what exactly I'm going to do or if we're going to start in on secant and cosecant right away or if I'm going to wait an extra day. So please let me know from the worksheet if you have a bunch of questions. All right, if you do, we can take an extra day looking at them, maybe look at a handful of them together, and then you finish them up on your own. But just don't turn this in if you feel like there's a high likelihood that you got a lot of mistakes. Okay, if you think you got a lot of mistakes, let me know which ones specifically you're trying and if you're struggling on them, and then we'll go from there. All right, guys? All right, just keep working hard, whether you're at school or stuck at home like me. Keep working hard. We're going to keep pressing forward because like I've told you guys a million times already, the more we get covered, the more I expose you guys to, the better off you are long run. Okay? All right, guys. That'll do it for today. Take care. Have a good day. Talk to you later.